Hi nerds, and welcome back to this little traffic lights project I'm doing right here. As I mentioned in the first part, this is not so much about the traffic light in itself. This is more a journey into coding and what's good code and when is code good enough. So always keep in mind, if all you need is a simple traffic lights controller like the thing we built in here in the first episode, you're done. This is okay. But what if we want to do a bit more? Say, makes the code more elegant, makes the code better readable, makes the code portable. So these are all things that we are going to play with today. Looking at the code, what can we make better? There's not so much we can do on the setup, so this will probably stay as it is. But looking down in the loop, there are 1, 2, 3, and 4. There are 4 blocks of code, which each has a definite function. And there's even one that repeats itself. And try, don't repeat yourself. So let's have a look if you can move those functions into real functions. So a function in C++ looks like that. You probably know this because setup and loop are functions, of course. So let's start with a function that doesn't have a return value, so it's called void at the start, and then we have stage red. Okay, let's write this. So this is my function, and I'm going to close setup here because I hate scrolling. Grab the red state and move it right in here. So this is red. The next thing we have is, let's do this up here. Copy stage yellow. And as we know, this is low on the red one and high on the yellow one. I'll close those two and paste in number 3. And of course, this is stage green. And you know the drill. So this looks much nicer. And when we now write the loop, I can get rid of all this. And in the loop, we now have stage red. No, it's a semicolon. Then, of course, we have stage yellow, and we're going to have stage yellow 2 times, because, And, of course, there's stage green. Would you look at this? Suddenly your program fits onto one screen. Nice! Just for the fun of it, let's take note of how many memory this needs. So our sketch uses 1050 bytes and uses 9 bytes for variables. So let's compile and see what happens. And of course, there's no change in the function because we didn't change a lot. But when there's a change, we use 20 bytes less memory. And this is because we call the stage yellow part, so this one, we simply call this 2 times. In the version we had before, we simply copied everything that was needed to have the yellow stage. And now we're simply calling the yellow stage 2 times. So we have less code than we had before. This won't hurt us on the CPU because we have tons of memory. But imagine you have a tiny CPU with, 2K, 4K of RAM. This could be the tipping point between code working and code non-compiling. One more thing, functions make the code way more readable. You simply go down to the loop and you know exactly what's going on. If you want to get rid of, say, the yellow stages, you simply command them out. You simply command them out. Now we have a simple red and green blinker. So, as a rule of thumb, when to use functions? Pretty much all the time. I always try to give a function a good name, a recognizable name. Same goes for variables, by the way. And since everything you do with a microcontroller is compiled anyways. You can go for really, really long names that describes what the function is doing in detail. So this looks like a good starting point for the next video. I'll leave it with that, and I hope I'll see you again in the next one. And yeah, see you there. Bye-bye.